we are going to study important aspect of leveling, that is refraction and curvature correction. What do you see in this figure? Look at this. It's very simple. We will try to understand. This is our level. We have labeled the instrument properly. Therefore, the vertical line is exactly going down. Now, horizontal line, as we have studied earlier, that is tangent to the level line. Here I have written correct level line for our convenience. Now see, this is horizontal line. Now this is the staff for symbolic representation I have drawn over here. Now see what happens. If we take this reading of horizontal line as a correct reading, then it will be more by some value. Look at this. Because when the instrument is like this, the curvature of the earth considering that particular aspect, then the level has to go like this. Unfortunately, it is looking straight. Therefore, instead of this, we get more reading like this. Now, in order to correct this reading, we will have to reduce this reading by some value. And this is owing to the curvature of the earth, we are getting excess reading. So that correction is called as curvature correction, and it is calculated as 0.0785 d square, where d is in kilometer and the correction is in meters. There is a derivation in the book, you can study that also for academic requirements. Fine. Now we will reduce this reading by this value 0.0785 d square, where the d is distance of that staff from the leveling instrument. Okay, fine. Another problem is also there. What? When we are watching through this telescope of the leveling instrument, because of the atmospheric layers of air, the reading which we get is lesser than the desired one. That is another problem. Now what happens? Because of that, we see the reading which is lower than the correct reading. So how to correct that? Then we will have to add some value to it. Now this is because of the refraction of the atmosphere, therefore it is called refraction correction. And how much is that? It is now positive correction, that is 0.0112 d square meters, where d is in kilometer. Now see, this correction is negative because it is coming down, and this correction is positive. But why to apply two corrections separately? So what we do is we combine both of the corrections, and then we call it as a combined correction, that is 0.0673 d square meters, that is negative, because this is large value, relatively this is smaller. So ultimately the sum or the combined correction is going to be negative, and that is negative by 0.0673 d square meters. So it is pretty clear now what is the curvature correction, what is refraction correction, and what is the combined correction. So whenever we take any reading, we will have to apply this. Now this can also be eliminated automatically, that we will see in other video. I hope you have understood this concept. Thank you very much.